Alright guys, so last time we talked about analyzing key features of a function, and today what we're going to do is we're going to talk about our parent function. And this should be pretty straightforward. I'm going to help you on the first few, and then I'm going to have you guys figure out some on your own. So what we've got right here, this is our f of x equals c. This is our constant function. I am recording. Thank you. You reminded me. Thank you. Okay, so give me some constants. 1, great. Give me another one. 2, great. Give me another one.
7.
Great. Is 3 halves, is that a constant? Is pi a constant? Pi is a constant. It's irrational, but it's still a constant. Now the question here is, guys, what will it look like if I just had the graph f of x equals 1? No matter what I plug into it, it just stays 1. So when I graph that, it's just going to look like this. Now what we talked about last time was how to analyze this once we have the graph. So here's our graph, and what we're going to do is go through and look at all of our key features. What is the domain? What's the range? What are the intercepts? Is it symmetric? Increasing, decreasing, constant, max and min. We learned about all of those last time, right? Now we're just going to apply it to our parent functions. Now domain, again, we could look at the graph and say which x values are there. The other thing would be, is anything going to make this blow up? Is anything going to make us divide by 0 or take a square root of the negative? And no matter what we plug in, what are we getting? Our constant. So our domain is going to be all real numbers. I'm going to show you a quick way to write it, just like that. Have I showed you that before? That fancy R just means all real numbers, or if you don't like that, you can do negative infinity to positive infinity. Or you can put that capital R, that works too. Now the range is the output, the y values that we see. And in this case, which y values are we seeing? Just 1. No matter what I plug in, all I'm getting is 1. So I'm going to write it like this. Bracket 1. So it's including 1, and then that is it. When we talk about our intercepts, we'll talk at x and y. Are there any x-intercepts? I'm going to put none. What is the y-intercept? 1, because everything was 1. As far as the symmetry, there were 2 types of symmetry, even and odd. Carson Murdoch, what does even symmetry tell us? Flipped over the y-axis. Is that what we see here? So this would be even symmetry. Good job. Now the other type was odd symmetry. What is that? Flipped about the origin, in other words, rotated 180. If I rotated that 180, it would end up at negative 1, so that doesn't work, right? All right, increasing is when it's going up. Is this going up? Nope. Is it going down? Nope, it's just constant from negative infinity to positive infinity. Are there any low points or high points? We're just going to say no, because it's just constant. Now, this is the most basic, okay? But it's important that you know the difference between a horizontal line and a vertical line. Horizontal is y equals. What is vertical going to be? X equals that one. And that will come into play later. Okay, let's go to the next one. We'll go a little bit faster here. We have what's called our identity function. The reason it's called that is because no matter what you plug into it, you get that back. So if I plug in 2, what do I get out? 2. So that means at 2, I get 2. If I plug in 0, what do I get? What if I plug in 8? What do I get? Yep. That's what it's at. So 8, 8. And so what that's going to make is this diagonal line like this. And I'm sorry if my picture's not perfect. It's kind of hard to draw on these things. But this is our identity function. No matter what you plug in, you're okay. Now, looking at this function, is there anything we can't plug into it? Is there anything that would make us divide by 0, or that would make us get a square root of a negative? No, because it's just, it gives you what you put in, okay? So what does that mean the domain is? The range is going to be the same, because no matter what you plugged in, you get the same in the increasing, decreasing, or constant? Good, 'cause we're reading it left to right, and it's going up. The whole time it's going up. So I'm just going to put from negative infinity to positive infinity, it's going up. Are there any max or mins? No, it's just constantly going up, so it's like that. All right, now what we're going to do, we'll do one more together, and then we'll go over the graphs, but I'm going to have you guys fill those in. Okay? So let's go to our next one. This one is our square function and our quadratic. Everyone show me what shape that looks like with your hand. There we go. This is our our parabola. Let's talk about how to get the points here. We're just going to square whatever we plug in. So I'm going to take 0 and square it, which means times it by itself. 0 times 0 is 0. 1 times 1 is 2 times 2. 3 times 3. Great. You've been working with quadratics since you're like sophomore year. Or if you're a junior, then like your 9th grade year. But the point is you've worked with them a lot. So now you can graph them. Hopefully you have it memorized. That it looks like. Here's your key points. 0, 0, 1, 1, 2, 4, 3, 9. When you square negative, it turns positive. So we get negative 1 is squared is 1, negative 2 squared is 4, negative 3 squared is 9. Okay, there is our parent function for squared, x squared. I want you to take 1 minute and try to fill in the domain, the range, the intercepts, and everything else, okay? 1 minute, go. All right, Adrian, help me out for this first one. What did you say the domain was? You guys agree? No matter what you plug in, you're not going to divide by 0 or get a negative square root. So it's all real numbers. Okay, what about the range though? Awesome. Do we include the 0 or no? We do include it because it's there. It's a point, right? Awesome. Okay, let's go to Kayla. What about intercepts? What do we see there? Yes. At 0, we have a x-intercept, which is also a y-intercept. So there we go. We're good there. Okay. And Kayla, also on you, what type of symmetry is this? This is even, because if you fold it over the y-axis, you get the same thing. Good job. All right, let's go to, gotta move my cards now. Let's go to our next one. Is this increasing, decreasing, or constant? We actually were going to get 2 here. So Jackie, what'd you say? You guys agree? Nice job. So it's never constant. And what about a max or min? What would we have here? Is there a maximum point or is there a minimum point? Is it an absolute or a local? Absolute. And where is that? What's another name that we call that point? For a parabola. What is that? That is your vertex. Good job. All right, so what we're going to do right now is I'm going to start helping you graph them, but then I'm going to have you go back and fill in the key information, because this could take a long time, right, going through all the graphs. Some of these you've seen before. For example, cube. What does it mean to cube something? Yep, times it by itself 3 times, right? So what's 0 times 0 times 0? 1 times 1 times 1. 2 times 2 times 2. Good job. Now what's tricky on this, what's negative 1 times negative 1 times negative 1? Negative 1. What's negative 2 times negative I'm not going to go through all this. You can do that on your own, okay? But do you get how to do that parent function? Awesome. Let's keep on rolling here. We're going to go to the next one. What about square root? Oh, okay. Is this one of our domain things we got to be careful of? What can't we have here? Negatives. So where is our first point going to be? What's the square root of 0? Alright. Square root you're saying. So let me, for those who are like, I never really understood square roots. Okay, let me give you just a real quick way to think about it. Pretend we're working with squares. Here's a square. It's not a good square. But let's meet, what is the definition of a square? All your sides are the same. And you got right angles. So let's say this is 3 and 3. What is the area of that? 9. So 3 squared gives you an area of 9. But let's say you start off with a square, and I'm told the area is 16. What's the side length? It'd be 4 and 4. So the square root is almost another way of saying, what is the side length of a square that has this area? Does that make sense? So if I have a square with area 1, what is the side length? So the square root of 1 is 1. I have a square with area 4, what are the side lengths? 2 and 2, so that means square root of 4 is 2, square root of 9 is 3, and this is actually the positive square root. If we're looking at the positive and the negative, that would be giving us a parabola here, but we're just looking at the positive square root. That's the graph. I'm going to let you go back and fill in the key information about is it increasing, decreasing, symmetry, all that fun stuff on your own. Now, when we take this to the next dimension, that's where we're going to get the cube root. So this is really going to test my skills here, okay? So let's say I've got a cube. A cube would be like a square, all the sides are the same, but in 3 dimensions. And let's say all the sides here are 5, 5, and 5. Instead of talking about area, what are we talking about? Volume. What is the volume of that cube? What is it? 5 times 5 times 5 is 125. So when I'm cubing something, that's what I'm doing. I'm taking all the sides and multiplying together, figuring out the volume. Now when I'm doing the cube root, what I'm doing on that one is I'm saying, hey, I have the volume already. Let's say that volume is 64. What would the side length be such that all the sides are the same? That would give me a volume of 64. That would be 4, because 4 times 4 is 16 times 4 again is 64. Good job. That would be your side lengths there. So we're not going to get that high up on ours, but let's do some easy cube roots. What's the cube root of 0? 0. What's a cube root of 1? What's the next cube root we're going to see? We're going to see, well, the cube root of 2 we don't know, but we do know the cube root of 8. The cube root of 8 is 2. Can we have negatives in cube roots? Yeah, because a negative times a negative times a negative is negative. So with the square roots, nothing was happening here because it was undefined because that gave us imaginaries, but we don't see imaginaries with cube roots. Cube root of negative 1 is negative 1, and the cube root of negative 8 is negative 2. So it's giving us kind of this S curve we saw before, but it's the other way. So it looks like that. That's a cube root. Did you guys work with that last year? I know those who had me saw. Did other ones see it? Maybe. Okay, some saying yes. I'll let you fill in the key information on that. But you need to memorize those key points. So if I just tell you graph your parent functions, you can graph it real quick. Okay, a couple more. Absolute value. What does absolute value do? What does that mean, though? Okay, let me give you my analogy for this, okay? Because yes, these are true, but not quite as in-depth as what I wanted. Let's say I told you I'm going out to lunch, maybe whenever lunch is. I'm going to go out to eat, and I'm going to go somewhere that's a mile away. Where am I going to lunch? Which restaurant did I go to? If I just said, oh, it's a mile away. We'll throw out some restaurants. Come on, guys. Could be McDonald's, but even then, which McDonald's? Could have been McDonald's down there, or, what's the other one? There's right there, right? Okay. So just because I said it's a mile away, did I tell you which way it was? Could there be more than one restaurant? Like, I could go to restaurants down there, but there's also McDonald's down there, or if I go like that way, I could go to a restaurant. Anyway, the point I'm trying to tell you here is when you do absolute value, it's telling you distance from zero. How far away the values are from zero. Well, this is going to give you more than one answer sometimes, okay? Because it could be positive or negative. But if you think of it as distance from zero, how far away is zero from zero? It's zero. How far away is 1 from zero? How far away is 5 from zero? So on the right side, this just looks like x, right? Because those are positive values. But can you go a negative distance? Distance is always positive. Just because I'm walking backwards doesn't mean it's negative, right? I'm still going a positive distance. So how far is negative 2 from 0? It's 2. So when I plug in a negative here, the absolute value of negative 2, it's a positive. So a lot of times people will say an absolute value makes a negative positive. Well, it's because it's telling you the distance, okay? And so on this side, the absolute value of negative 5 is positive 5. It's making these positive, and that's how we get our V shape. You've seen that before, right? Absolute value, we're good there. Let's keep on rolling. We've got just a couple more here. We're going to get into some ones that maybe you've seen and maybe you haven't. This one's a little tricky. It's called the reciprocal function. Do you remember this from secondary 3? 1 over x. What's the one thing we can't plug into this? X can't be 0. So what does that give us at 0? We've got this asymptote, a vertical asymptote. What's the rule with asymptotes? The rule is you don't touch that asymptote, okay? All right. How many of you had Miss Allen? Did she teach you a fun way to remember it? No? We don't have to share. We all know what you're going to say. Okay. Let's keep going here. What we're going to do, whatever we plug in, it just flips it over. What's the reciprocal of 1? So if I take 1 and I plug it over, 1 over 1, what is that? So 1. What about if I plug in 2? What's the reciprocal of 2? And then I get 3 is 1/3, 4 is 1/4. And what's going to happen is I keep going to the right. Does it ever become 0? So what does that tell us? There's also a horizontal asymptote at 0. So it's getting closer and closer to 0, but it never touches it. Now, right here, what's the reciprocal of 1/2? 2. What's the reciprocal of 1/4? And so on and so on. So what we get is this shape right here. Now that's only for the positive side. Does that make sense why it looks like that? Good. Now what we're going to do is now go to the negative. When I take the reciprocal of a negative, does it change the sign? No, it'll still be negative. So what's the reciprocal of negative 2? If I take negative 2 and I flip it over, it'll be 1 over negative 2. So that's going to give me this point right there, negative 1/2. Shout out with me, what's the reciprocal of negative 4? Negative 1/4. What's the reciprocal of negative 1/2? Negative 2 though, right? So what's going to happen here, guys, is I'm going to get that same shape as what we got on the other side, but it's going to be like that. This is what I call the ninja star. Because can you see with the asymptotes, it kind of looks like a ninja star. It's not that, but whatever. Okay, are going to go through and do the key features on this one. Actually, good. Minute head start. Try to fill it in on your own, and then I'm going to check them. Go. Okay, 10-second warning. Move on real quick here. Caitlin Shamma, what did you say about the domain?
It's negative infinity, comma, 0, meaning that 0, comma.
Alright, so basically, it's everything except what? X can't be 0. There you go. Because we've got that vertical asymptote here. X can't be 0. What about the range, guys? Same thing, except this time y can't be 0, so it's going to be the same thing. So notice with the 0 here, we're doing parentheses because we're not containing that one. Okay, good job. That's domain range. Duke, what about our intercepts? Exactly, there's no intercepts. Because we've got those asymptotes. We can't be on the x or y axis. Ruth, what about symmetry? What kind of symmetry is this here? Is that odd, even, or neither? It is odd. If I rotate that 180, it lands on itself. This is odd. And we could also check it by plugging in a negative x, and it's the same as timesing by a negative, so we're good. Alright, we're almost there. Evelyn, is this increasing or decreasing or constant? Let's start out clear over on this side. Someone might say it looks like it's constant right here, but is it the same? No, so if I start over here, what's it slowly doing? Decreasing all the way to there. So I'm going to say it's decreasing from 0, or sorry, let's change that, from negative infinity to 0. There we go. But then when I start clear up here, what's it still doing? Decreasing. Now, someone's like, well, it's decreasing the whole time. Why did you write it like that? Well, because I can't say it's decreasing at 0, because nothing's happening at 0, right? So that's why I wrote it like this. Any max or mins here, guys? Nope, we're good. Does that make sense? Do you feel a little more comfortable with these? Going like that. Okay, we're almost done. We're going to go to, I think this is our last one. And then we've got piecewise.